Hello and welcome back. Today we're going to look at the binomial theorem in section 9.5, and we want to consider the pattern when we FOIL or when we distribute out these binomials. So x plus y to the 0, well, that just equals 1. X plus y to the 1, that equals x plus y. And then we know when we FOIL the binomial, we get x squared plus 2xy plus y squared. And we can keep going with higher powers of x plus y. But you can probably tell that it starts to get exhausting doing all that distribution. So what I'd like to introduce to you today is Pascal's triangle. So Pascal's triangle is actually a pattern where we have the edges here are all going to equal 1. And then the numbers on the consecutive rows are going to be the sum of the two numbers right above it. So if we have 1 plus 1, that equals 2, 1 plus 2, that equals 3, 1 plus 3, that equals 4, 3 plus 3 equals 6, and you can see that pattern. So we're going to make sure we use this pattern when we look at simplifying or expanding binomials. So n will be the degree of the polynomial, and whenever we consider how many terms there'll be, there will always be n plus 1 number of terms. So what that means is when we had this x plus y squared, n was 2, and we had 3 terms. When x plus y is raised to the 4th, we're going to have 5 terms. The variables for x will decrease. So we have 5, 4, 3, 2, 1, and then 0, because that simplifies to equal 1. The exponents of y will increase. So we have no y here, so that's y to the 0. Y to the 1, y squared, y cubed, y to the 4th, y to the 5th. Okay, whenever we have two variables, so looking at these degrees, okay, so we know that the degree of this last row, x plus y to the 5th, the degree is 5. So each of these variables, these terms, must have a degree of 5. So x to the 5th, that's easy. But we have x to the 4th times y. So that really has a degree of 5, 4 x's and 1 y. Here we have 3 x's and 2 y's, again adding to equal 5. So the sum of those powers for each term will always equal n. The binomial theorem helps us to determine those coefficients and defines x raised to the n minus r times y to the r as n choose r. And n choose r can be written as n factorial over n minus r factorial times r factorial. So another way to also write this is with parentheses. So let's consider each of these, and I want you to try to calculate them with factorials. So pause this video and come back to check your answer. Okay, let's check our answers. So 9 choose 2 would be 9 factorial over 9 minus 2 factorial times 2 factorial. And we notice that 9 times 8 would be left in the numerator because it's 7 factorial in the denominator. So 9 times 8 divided by 2, 72 divided by 2 is 36. Now let's go to 11 choose 4. So we have 11 factorial over 11 minus 4 factorial over 4 factorial. And again, 7 factorial is in the denominator. We cancel the 7 factorial in the numerator, and we'd be left with 330. All right, 8 choose 0. So we have 8 factorial over 8 minus 0 factorial, which is 8 factorial, times 0 factorial. So that's just going to equal 1. And 5 choose 5, well, that's 5 factorial over 5 minus 5 factorial times 5 factorial. So that'll equal 1 as well. Now I want you to take notice of these numbers. So when we look at the 5th row, and I choose 5. So I'm going to start with 0. So 0, 1, 2, 3, 4, 5. That number is 1. And that's what we got when we had 5 choose 5. Now let's look at the 8th row and look at 8 choose 0. And 8 choose 0 is 1. We also got 1 there. Let's look at the first one, 9 choose 2. So we're looking at the 9th row. Remember, we start with 0. So 0, 1, 2. We get 36. And remember, we got 36 for 9, choose 2. Hopefully you'll notice that the coefficients are going to match the values also in Pascal's triangle. So let's just look at values of n and r. So if we have 8, choose 5, well, that equals 56. What's 8, choose 3? That's also going to equal 56. If we look at 6, choose 4, well, 6, choose 4 equals 15. And if I have 6, choose 6 minus 4, which is 2, I'll also get 15. Now 14, choose 1, that's just 14. And then 14, choose 14 minus 1, which is 13, will also equal 14. So thinking about the values in the Pascal's triangle and the relationship between the degrees of x and y, or n and r, well, let's look at the table. So we could tell right here that the values are symmetrical. So if we have 8 over here, we're also going to have 8 over here. And you can see 28, 56, and the number in the middle is 70. But if we have two numbers, 126 and 126, we have that symmetry in the binomial expansion. All right, a little bit more about Pascal's triangle. So Pascal is credited with discovering this pattern, but it was actually discovered much earlier and called the precious or jade mirror of the 4 elements in 1303. We always call the top row the 0th row because it corresponds to x plus y raised to the 0, which equals 1. So the nth row of Pascal's triangle gives the coefficients x plus y raised to the n. Now let's consider the first row. So we know the first row is x plus y raised to the 1. That's not a mystery there. But we can rewrite the coefficients as 1 choose 0 times x plus 1 choose 1 times y. So again, using that definition, we have 1 factorial over 1 minus 0 factorial times 0 factorial. That equals 1, and 1 choose 1 also equals 1. Let's look at the fifth row. So for the fifth row, we have x plus y raised to the 5th, 5 choose 1, for x to the 4th times y. And we know if we're looking for the coefficient of x cubed y squared, that would be 5 choose 2, which is 10. Now let's look at the 8th row. So if we wanted to rewrite this, we know what that's going to be. Start with 8 choose 0, 8 choose 1, 2, 3, and you can see this all the way till we get to 8 choose 8. 8 choose 0 and 8 choose 8 equal 1. 8 choose 1, 8 choose 7 equal 8. 8 choose 2 and 8 choose 6 equal 28. 8 choose 3, 8 choose 5, both equal 56, which we found out on the previous page, and 8 choose 4 equals 70. Now let's look at the 9th row. So we can use Pascal's triangle. You can add these together, or we can rewrite them with the definition. So we have 9 choose 0. I'll just use a comma here. 9 choose 1, 9 choose 2, and then just keep going until I get to 9 choose 9, if I can fit it on this page. Might run out of room here. And then 9 choose 9. And then when we calculate it, well, and you can also confirm it with Pascal's triangle, but this will be 1, we have 9, 36, 84, 126. I'm going to put a comma here so we can see it more clearly. 126, 84, and again, it's symmetrical, so now it's going to go down, so 36, 9, and back to 1. Beautiful. Okay, so now we're going to use what we know about binomial theorem, Pascal's triangle, to expand these binomials. Let's write the expansion for x plus 2 raised to the 4th. So remember, for the coefficients, we'll have 4 choose 0, And we're going to start with x to the fourth. And then we'll have 4, choose 1. The degree for x will go down, and the degree for y will go up. Then we'll have 4, choose 2. X squared, y squared, plus 4, choose 1. X times y cubed. And our last term will be 4, choose 0, y to the fourth. Again, I used x and y just as a general pattern. But for this binomial, we're going to substitute and make our y equal to 2. So I'm just going to simplify everything. So we know that 4 choose 0 equals 1. So we'll just have x to the fourth. 4 choose 1 equals 4. We have x cubed times 2. Or we're replacing all the y's with 2. 4 choose 2 is 6. X squared, 2 squared. Plus 4 choose 1, which is 4. X times 2 cubed. And then 4 choose 0, back to 1, but our y was 2. Now let's just simplify this a little bit more. So we have x to the fourth plus 8x cubed. That'll be 4 times 6, that's 24. X squared, that'll be 8 times 4, which is 32. X plus 2 raised to the fourth, which is 16. So now we expanded x plus 2 raised to the fourth. Example 4 looks very similar, but this time I'll substitute y with -3. So I'm just going to use the pattern we have up here. All right, so we have x to the fourth plus 4x cubed -3 in place of y, plus 6x squared -3 squared, plus 4x -3 cubed, plus -3 raised to the fourth. When we simplify this, we get x to the fourth, I mean -12x cubed, plus 54x squared, -27 times 4, that's going to be -108x, and plus 81. So expanded that binomial. What's important to notice, when we have a minus sign or a subtraction in the binomial, the signs are going to alternate. So you might notice it is positive, negative, positive, negative, positive. So you really have two choices when substituting. You can either use y equals 3 and then alternate the signs, or, like I just did, use -3 for y. For this last example, we're going to substitute both the x and the y. Sorry, there's a lot of variables here, very similar. But instead of x, I'm going to put 2x. And instead of y, I'm going to put -y. All right, so we started off with x to the fourth, but now I'm going to write 2x raised to the fourth. The coefficient was 4. We're going to have 2x cubed and times -y, plus 6, -2x squared, -y squared, plus 4, -2x times, it's going to be a -y cubed, and then our last term will just be -y raised to the fourth. Now let's simplify. So 2 to the fourth, that's just going to be 16. X to the fourth, we'll have -32 x cubed y, and then positive, so plus 24 x squared y squared, and then minus 8xy cubed, and finally plus y to the fourth. Right, so simplifying those wasn't too bad using the binomial theorem. Now we're going to expand 3 minus x squared raised to the fifth. And I'm just going to rewrite it a little bit. So -x squared, we're going to plug that in for x and 3 in for y. So our degree is 5. So we'll start off with 5, choose 0. negative x squared raised to the 5th. 5 choose 1, negative x squared to the 4th now times 3. 5 choose 2, negative x squared cubed, 3 squared, plus 5 choose 3, negative x squared squared, 3 cubed, hopefully I can fit this in here, plus 5 choose 4, negative x squared times 3 to the 4th, and then 5 choose 5, 3 to the 5th. Okay, barely fit in there. Okay, let's simplify the coefficients. So we'll have negative x to the 10th plus 15 x to the 8th. This will be a minus 90 x to the 6th plus 227 times 10, so that's 270 x to the 4th minus 3 to the 4th, 81 times 5, so that's 405 x squared. And last but not least, 3 to the 5th, 243. This is the binomial raised to the 5th in simplest form. For the next example, we're just going to find the 5th term of this binomial expansion. All right, so going back to the definition, our n, the power, is 8, right? It's raised to the 8th. Our r is going to be 1 less than the term. Remember, we actually start with a 0 term. So 5 minus 1 would just be 4. Our x, in this case, is going to be a, and our y will be equal to 2b. So if we want to figure out the term, or it's going to be 8, choose 4, and then we're going to have a raised to the 8 minus 4, and 2b, I'll write 2b here, raised to the 4th. Okay, just notice that this term, this number, that r, is also right here. That's the same r. Okay, and then the difference between n and r will be the exponent for the first variable. All right, 8 choose 4. That's going to be 70. And then we have a to the 4th. 16, b to the 4th. And then 70 times 16 would just be 1,120. And we'll have a to the 4th, b to the 4th. All right, now for the last example, we want to find the coefficient of this term given the expansion. At the degree, well, that's just 11. We can see that here, right? And we can also add 4 and 7. Remember, we were talking about the r being equal to the exponent of the second variable. So that's going to be 7. And so if I wanted to write this out, I just want to make sure I make my x was 2a and my y is negative 3b. Now, because they have coefficients that are different from 1, this will affect the coefficient of the whole term. Okay, so let's write this out. So this will be 11, choose 7. We'll have 2a raised to the 11 minus 7, and negative 3b to the 7th. So 11 choose 7 is 330. 2 to the 4th, 16. A to the 4th. Negative 3 to the 7th, that's negative 2,187. B to the 7th. And now we just need to multiply 330, 16, negative 2,187. The coefficient will be negative 11,547,360. Okay, I hope that was helpful, and I'll see you all in class.